Assalamualaikum, Bismillahirrahmanirrahim. Rabbi Shari Sadri, Vayasirli Amri, Walulugdata, Milisani, Fokoli, Rabbi Ziti Ilwa. Okay, now children, we are here with more of chapter number 7, that is 7.3, explaining the purpose of algorithm and what is the requirement here. Again, you can see another example. An algorithm sets out the stages to complete a given task. This is usually shown as a flowchart or pseudocode so that the purpose of the task and the processes need to be completed are very clear to those who study it. Now, just remember, this is just a mean that is helping us out in the designing. Remember one thing, just like the architects are doing what? They are doing the same thing. Similarly, when you talk about the flowchart or the pseudocode, they are also meant for the designing purpose. So this is a very simple flowchart. Start, input num1, num2, num1 greater than num2. Yes. See, remember this is what we were talking about. Yes. So print num1 is larger, else print num2 is largest. And the use of the lines, please be very clear. The flowcharts are composed of lines and the flow. If the condition is true, it will move to yes and the use of yes and no. Again, a suggestion that whenever you are going through any of the flowcharts, just see that how the flowcharts are constructed. So if they give you just one thing that asks you to design a flowchart, you know what you need to do. And this is going to be a very simple activity. Print num1 is largest, and then you finish it here. Print num2 is largest, and then you finish it here. And you can see the flow lines are moving from here to here. And then you make the symbol for stop, and this is how you finish your flowchart that is meant to handle input of two numbers and finding out the bigger of the numbers. So this is a very simple question. Now, written in this manner, mashallah, you people know it very well. Input num1, comma num2. If num1 is greater than num2, then print num1 is larger, else print num2 is larger. So, by the way, do not get confused at how the print is written in the same line or whatever. So, whatever you have learned, just carry on with the same activity, and inshallah, you'll be through and you'll be able to attempt. Now you can see purpose. This is the purpose. Now you can see you are given a flowchart, you are given a pseudocode, and you are asked the purpose. So you can see for yourself what is happening. First thing is we are taking input of two numbers that will give you 1 point, and divide the larger number. Actually, now this is simply talking about the which is the bigger number. The bigger number, just find out and print the bigger number. That's perfectly okay. Now this is another one that is you can say that the question is given to input two numbers, divide the larger number by the smaller number, and output the result. So this is also an example of a purpose. So if you are given this question, you can write a pseudocode, mashallah, very well, can even draw a flowchart, and that is not going to be a problem. So this is what the purpose is, what the things are doing. Now, very quick recap, standard methods of solution, what we talked about. You need to be able to use and understand these standard methods used in algorithms: totaling, counting, maximum, and minimum. So let's see. Again, the same repetition. Totaling means total variable will be initialized outside the loop with 0. Loop is going to start for count equals to 1 to class size or whatever the value is. If you are given a value, that's perfectly okay. If you're not given a value, then you can use a variable also, because again, the way, for example, if I have a class size, maybe one class is going to be 50 students, another class can be 10 students. So the value is going to be variable. That's why we go with a variable here. I think that is very clear. Variables are simply used to mention that what is the class size, which may vary from person to person. Input mark, total, assignment operator, total plus mark, and just be very clear again, beta. Total assignment operator, total plus mark. And then you finish with next count. So, and you can see the purpose of totaling is totaling adds up all the marks for students in the class. And if you're asked to explain totaling, this will definitely give you 1 out of 1. When totaling, the total is increased by the value of the mark. Always set the total to 0 before checking the mark input. So these are the 3 stages that we talked about and discussed here. Initializing done before the loop starts. You have a loop here. Input taken inside the loop. Totaling done inside the loop. And then you can output it outside the loop. Any questions? The first standard method of solution is your totaling, and that is done. Then counting, again, as the name implies, counting counts the number of students whose mark is over 50. This is just an example. Again, you have initialized the variable pass count. There's only one situation. I simply wanted to figure out that how many of my students have passed. So that is why I only need to initialize one variable with 0 again. Again, a loop, input taken inside the loop, condition checked. If mark is greater than 50, then pass count equals to pass count plus 1. So see the use of plus 1. Plus 1 is indicating, this line is indicating that it is your counting. And this line is indicating it is your totaling. So if anyone asks you to explain totaling or counting by given example, so you can simply mention these and use of the appropriate variable names and use of the appropriate identifiers will definitely give you an edge over the others. So this is just an example. When counting, the counter is always increased by 1. So this is something that we need to know, that in counting, the value is always increased by 1. Any questions? G children, any questions till now before we proceed? Okay, now the next one is finding maximum and minimum. And maximum and minimum, again, you can see all the things are handled together. So you are you have three variables. One is total equals to 0. Max marks is initialized with the least abnormal value. Min marks is initialized with the something that is non-attainable. Or maybe you can go with 101 or 999 also. 1 to class size, input mark, and if mark greater than max mark, then max mark equals to marks. End if. Two separate ifs to handle maximum and minimum. Be very clear about it. I'm repeating. And then you can see the total is also done in the same loop. No separate loops are needed. This is what you need to be very clear. And this simple program will help you a lot in your scenario-based questions, because scenario-based are somewhat similar to what we have just done. You are given one question, you will use only one loop, and you will perform all the activities, whether it's counting, maximum, minimum, or whatever, inside the same loop. So this is what is the main thing. Again, see what are they describing. To find the maximum and minimum values, every value must be checked. To find the average of all values must be total when divided by the total number of values. Always set the minimum value to the largest value possible. Always set the maximum value to the lowest value possible before checking the mark input. When this is what they are mentioning. Minimum value is initialized with the highest possible value, and maximum value is initialized with the lowest possible value, because that will be definitely the attainable values. And then average is done in a different manner. Again, this is why they have shown it again, that whenever you need to find out the average, you need to total all the values together, and then you find out the average in this manner. Average, assignment operator, total upon class size. So this is how the average is calculated, the maximum and minimum are done, and this is done. Now moving to linear search. Any questions till now before I move to the linear search? Any questions? Because now we are moving to linear search and bubble sort, which are going to be very important for you people. So if there's any question, then ask, otherwise I'll move further. Okay. Linear search means that first of all, you need to be very clear about the arrays. I hope that we all are clear about arrays. Why do we need an array? Yes, are we all clear about arrays? Simple. Where the question, the thing is very simple. See, if I am doing everything till now, what has been happening? Whenever we talk about whenever we talk about the simple variables, so what happens? The values are overwritten. But when I want the values to be stored of the same nature, like maybe I want to store the marks of my class, I want to store the names of my class. So in this manner, I can have multiple arrays to store the values of same nature. One array to store the names of my students, another array to store the marks of my students. So here, just be very clear, Chabat. By the way, one more thing is the identification of this variable is an array basically. This is the identification. So just see very quickly a linear search. What is linear search doing? A linear search is simply inspecting each name. Now in this case, enter the name to search. And you are taking the input in a simple variable first. And then I will suggest you that you can take S name, for example. Input S name, found equals to false, counter equals to 1. Repeat. If S name, which is your student name, equals to name of counter, then found equals to true, else counter equals to counter plus 1. Until found or counter greater than class size. So just talk about this, my repeat until loop, and we prefer to use a repeat until or a while loop in order to perform linear search. So you can see here, one by one, if for example, my class size is maybe 5 students right now. So one by one, if for example, I say I want to find Ali, and Ali's name is existing maybe somewhere on the third location. So one by one, it will be searching all the values and will be now figuring it out that which input is meeting the criteria. And then, okay, now just give me a minute. Let me open another file and then I'll share it with you. Just give me a minute. Now, method of solution, once again, be very clear. Methods of solution is something that you need to know, and this can come in your paper. Now, this is just one more example to make you understand that how the linear search works. Okay, this is just an example. One more example. And let's take the simple example of 5 marks. So the moment you don't understand, please stop me. My array is by the name student marks, and it is of 5 values. I'm storing the name, I'm storing the marks of 5 of my students. And you can see index. Index is holding 1, 2, 3, 4, 5 because there are 5 students in my class. And the values that are here, you can see first student's marks are 34, second student's marks are 67, third student has scored 45, fourth has scored 78, and the fifth one has scored 65, for example. Now, these are the 5 marks that are already stored in the array. And I am asked to go for linear search, just finding out that whether the item is existing in my array or not. And here you can see this is the just a few example. First one is 67. So what will happen? First thing is input of item after a message for the user that input which item do you want to search, and the variable found is initialized as false because in the beginning element is not found. Index is 1 because we have to start from the beginning. Repeat, and you can see it's very simple. Just think from real life. If, for example, I was asked to maybe search for a book, I'll start my search from where? If I went to the cupboard and I wanted to figure out that whether the book is in the cupboard or not, so I'll start from the beginning. That's why you can see index equals to 1. And then you will keep on comparing the elements with their respective values. So first time, the value of is present as 34. So 67 was compared with 34. Are they equal? Yes, children, are they equal? 67 and 34 are not equal. That is why the found value will not be true and it will move to the else and it will increase the value of index by 1. The value of index will now become 2. And it will check until found equals to true. Is the value of found true or is the value found still false? Yes, children, is the value of found true or false? At the moment, it's false. Or index greater than 5. The value of index is not greater than 5. It's again 2. 2 greater than 5, both the conditions are false. And we have just talked about that both the conditions are false means it will move back to the repeat. And now it will check with the second location's data. And this second location is 67. So 67 and item 67 are matching. So definitely if the items are matching, it will be moving to the condition being true, it will move to this line and found will be true. And since found is the variable is now true. So you can see here, now it will not enter into the else situation. It will move here and say until found equals to true, which is now true or index greater than 5. So although the element, the value of index will not be increased by 1, the value of index will remain 2 and the value of found will now become true. So it will not be moving back to the repeat and it will move here to the if. Any questions till now for the first situation? Yes, children, be clear. Are you clear about it? Okay. Now moving to this is a very simple concept of linear search. Just remember that first thing that we do is we take the input, then we have two variables. First one is a Boolean variable, which is initialized as false. And then another one is my counter or index. Normally we can take any variable. You can say C or counter or index or I or whatever. But just one caution, if you have used index, then you have to use throughout the value as index. You will not make it counter or C or anything like that. And this is what you can see I've highlighted also. Index used here, so index will be here. And the value of index will be checked and the value throughout it will be index. And this is what is the indication of an array. Now moving to if found equals to true, then output item is found, else output item is not found. So since this element has been found, so that is why a simple message for the user item or whatever you can see. If you really want it to be a little better, the way the scenario-based questions are expecting us to write meaningful, you can say messages also. So you can just go with this manner also. Item, which is 67, is found at position 2 in the list. That will give you a very comprehensive, good answer for you to score a good mark. Now, moving to second situation, just giving you an example to make you understand that along with that, we have 99. Now you can see for yourself, I mean, you being a human can do it very fast, mashallah. But you can see 34 is compared with 67, oh sorry, 99 not equal. Then 67 is compared with 99 not equal. 45 is not equal to 99. 17 is not equal to 99. Even 65 is not equal to 99. It means in all the cases, value 99 that was input by the user as the second input was compared throughout, and none of the items in the array were matching with the value enter, that is 99. So definitely the whole loop is over, and the value of index will now be increased by 1. It will now become 6. 6 greater than 5. Although the value of found is not true, the value of found is still false, but the value of index has become more than 5 because now it has reached the end of the array and still the element is not found. That is where you can see in your linear search algorithm, if you are using repeat until, then you need to be very careful about the use of until, found equals to true, or index greater than 5, or whatever the value is. If there are 10 elements, then you will go with index greater than 10. If there are 20 elements, you will go index greater than 20. So this is a simple rule that you need to remember for linear search. And again, the same, once you are done with the linear search, then you go with the if and you check that whether the item is found or not. If found is true, you have a message for the user, item is found, else item not found. That's all. Dear children, any questions? May I move to bubble sort? Again, you can see something similar to this one is there. Only the change is the use of this class size as a variable. And here I have used a 6 fixed value. That's perfectly okay. So just a repetition, a reminder for whatever we have been doing. So is there anything that is confusing you people? Are you clear about this? So the same thing I did. The only change is I have used a value because I had 5 values. That's why I said greater than 5. You may have a variable just like the class size. So they have taken the example of something similar to what has been in your past papers. Okay, fine. May I move ahead? And then a simple one. If found, then I output name found, else output name not found. By the way, if found means what? If this is only written, so what will I assume? Is the value of found true or is the value of found false? True. Great. And if I really wanted to show false, then what is the other method? Like there are two ways of doing it. Either I have if found equals to false, or what else can I say? See, this is what I'm writing it for you people. Found and found equals to true are same. Similarly, if I ask you not found, then how do I write it? Found equals to false. How do I write found equals to false? G. What is the other way of writing it?
Not found.
Excellent, not found. So just be clear. This is something that can come in the paper. This has been coming in the paper. So do not get confused that I don't know it. You're simple. If it's written found means it is true. If it's written not found, it means it is false. That means the same. Okay, children, are we clear about this? Maybe move to bubble sort. So by the way, bubble sort. A very interesting thing, a few things that you need to remember for bubble sort, and then bubble sort has actually been like there in our scenario based questions, although it has been a part of many of our debugging questions. So just be very clear. The moment you don't understand, please interrupt me. Please just send a message that I'll be able to solve your problem just then and there. First thing that you need to be very clear about is bubble sort is there to compare each value with its adjacent value. And this is going to, like you can see, a bubble sort compares each name in the list with the next name and swaps them in the names and swaps them if the names are not in the right order. starting from the beginning and finishing with the next to the last item. Last, and by the way, just making it simple for you, this is just an example. And here, this is bubble sort. Be clear, sort means arrangement. And a lot of questions in our past papers, like let me tell you, for those who are beginning to practice inshallah today, bubble sort has come in our questions of flowchart. They have come in our questions of pseudocode writing. They have come in order to, like, scenario-based question. I said that in November 2025, paper 2's scenario-based question was dealing with same bubble sort. So this bubble sort has been coming quite frequently in our paper. And this has come in quite often in our debugging questions. So just try to understand what is the mechanism. Before we proceed to the actual pseudocode, let me talk about the concept. Right now, I have 4 elements. You can see. Okay, now. I've just taken some imaginary values to make you understand, and I hope that that will make your concept very, very clear, inshallah, in a fraction of. Let me do one thing. First one is my elements 45, 67, 13, and 9. I've just taken 4 values right now, and let's see how bubble sort performs the activity. The way it said, you have to compare the first and the second element in the beginning. Like, first element will be comparing 45 with 67. Is 45 bigger than 67? Yes. Is it bigger? No. So they remain in their positions. So first time the comparison was made between the first 2 elements, and you can see the first 2 elements are 45 and 67, and these two were compared. Fine? They were compared. No change has occurred because 45 is not bigger than 67. Then comparison was made between 67 and 13. Is 67 bigger than 13? Yes. So what happens? This value 67 goes to a temp location. Just remember, this variable can be temp, t, swap, or whatever. Like, they can use any variable, but just be clear, we will be using a temporary variable to hold an item for a moment. And once the second element has moved to this location, then only the value will come from temp to the second location. I'm saying second location because now it is not second or third, it is now first and second. Assume them in this manner. Comparison was made between 67 and 13. 67 is bigger than 13. Condition is true. So 67 has moved to a temp location. The value of 13 has come and is placed on position number 2. And 67 that was earlier in temp location, or t variable, is now going to move to the third location. Or you can see the swapping has been done between 2 students. Assume in such a manner that maybe a student A, Ali, is there, and a student Zain is there. So I want Zain to come and sit in front, maybe, or maybe I want Ali to go at the back. So what will happen actually? This is how the swapping is done. If Ali is seated on the first place and Zain is seated on the second chair, and I want Zain to come and sit on the place of Ali. So first of all, Ali will stand from his position. He will vacate. He will stand in a temporary location. The position is now empty. Now Zain will come and sit on Ali's place the way 13 has come, and assume these are not as 67 and 13. Assume them as Ali and Zain. So Ali has moved from his location to a temp location momentarily, maybe for a second. Now Zain will come and sit on the place of Ali, and now Ali will come from the temporary location to Zain's position. Ji children, are you clear about this main thing? If you are clear about this, only then the whole concept will become very easy for you in order to apply it yourself also. Any questions? Now, next time it will be comparison between 67 and 9. By the way, will they be swapped also or not? Yes, will they be swapped? Is 67 bigger than 9? Okay, now what should I repeat? See, first of all, I was just giving an example of not the elements. I was talking about the students. 2 students are there. One is Ali and second one is Zain. So if I want Ali to move back and give the place to Zain, so what will happen actually? First of all, Ali will stand up from his position. He will go to a temp location. You can take an example yourself, even if you are with your sibling. If your mother wants you to go back and your sibling to come in front, then this is always happening in real life also, that you vacate the position, and then only the second person can sit and can come and sit on your position. So this is how the whole process of sorting is taking place. A temp location is needed to hold the data temporarily. Are you clear about this? This was just an example to make you understand the concept that is used in your sorting. Children, any questions now before I proceed to the... Okay, now, if you have understood this, and I think it will become very easy. Now, 67 and 9, will they be swapped or will they remain in their positions? 67 will again be swapped, and you can see again the same process. 67 will move to a temp location, 9 will come on the position of 67, and 67 will come from temp location to the fourth position. And in this manner, by the way, is there any further need to go further, or has the work been completed? You children, are we clear about this whole process? Now we are done with this, and you can see this is my pass one. And with pass one, the highest, or they can say the maximum, the highest element has moved to its location. Like that has moved to the last location. Now these are my elements: 45, 13, 9, and 67. Now I'll be comparing the same first to 45 and 13. Is 45 bigger than 13? Now I'm starting my pass two. Now my next value is, now my pass two has started, and it will be now comparing 45 and 13. Will 45 and 13 be swapped? Is 45 bigger than 13? Dear children, at least let me know, is 45 bigger than 13? Yes or no? Yes, it is bigger. Yes, it is bigger. So definitely the same process will be done. And now I'll be doing a little faster. So I hope that there's no confusion. 45 is bigger than 13. So 45 will move to the temp location. 13 will come and be there, and 45 will come on the second position. So this is how the comparisons were done. The values were swapped, and this is now over. Now, second time it will be comparing 45 and 9. Is 45 bigger than 9? Yes, again, 9 will come here, 45 will come here, and again, the same concept of temporary locations being used to hold the data temporarily, and the values will be swapped in the same manner. Remember, real life, talk about computer, sorting is always done, arrangement is always done by putting one value at least at a temp location for some time, and then we move further. Yishan, are we clear about this completely? Any questions? 45 and 9 were compared. 45 has swapped the position with 9. And by the way, is there any need to compare 45 and 67? Just asking you. Is there any need? There's no need, because first pass, one value, the maximum value has reached its position, and with the second pass, the second maximum has reached the position. So there's no need to go further, although you can. But if I say efficient algorithm, efficient means there's no need. So we better go with an efficient algorithm, and that is the use of efficiency. If there is no need, then there is no need to go any further. Although I'll go for pass 3, because I now need to compare the first and the second element. Are you getting it? 13 and 9 will be compared. Is 13 bigger than 9? Then this is part is pass 3. So bigger than 9. That's why 9 will come on the position of 13, and 13 will move from its location to second location. And in this manner, with pass 3, all the elements have reached their respective locations, or in other words, you have sorted the elements, and this sort arrangement is called bubble sort. There are different other sort algorithms also, but that is not a part of your syllabus, so just restrict yourselves to the concept of sorting, what sorting is, and the bubble sort, the term bubble sort. It's a kind of sorting algorithm, and that's all. Now, let's move to a few other important things. Remember, one important thing is the number of passes. The number of passes is always 1 less than the number of elements. If there are 4 elements, the passes are 3. As you can see here, you just, like I did it in your presence. If the elements are 100, the passes will be 99. This simple rule, the number of passes is always 1 less than the number of elements in the efficient bubble sort algorithm. Second thing is, now if this is clear, then let's move to the other things in the same sorting algorithm. No confusions, no problem. Second thing is, when you talk about the sorting algorithm, then inner comparisons are always decreasing. First time we compare 3 times, as you can see. First two elements were compared, then second two elements were compared, then second and a third were compared, then third and fourth were compared. So this is your inner comparisons are always decreasing by 1. And that's why here I wrote 4 minus 1. Then I wrote 4 minus 2. Again, you can see there were two comparisons made. And then it was only one comparison made. There was no need to go any further. That's why it was done with only one comparison. There was no need to go further with comparison of 13 and 45, then 45 and 67 at all, because we already have placed them in their positions when we were traversing, when we were doing the sorting. Dear children, any questions till now? Passes are always one less than the number of elements, and the inner comparisons are always decreasing. And one more thing which you can observe from here, if pass is 1, the number of elements is 4, so 4 minus 1. Pass is 2, so it means it will be 4 minus 2 comparisons. Pass is 3, total elements are 4, 4 minus 3 or 1 times comparison is done. So if you're clear about this whole structure with some imaginary values, then now move to the pseudocode, and this is again very simple. And just put it in the right order to make you understand that how it works. Now here we can see first is 1 because I have only, again, let me take the same example. I have first, so by the way, these are simple variables. You may have some other variables in your question paper, so do not get worried that the questions are different. It can be any. First equals to 1, last equals to 4. I have two variables, first 1, last 4, because I have 4 elements. Repeat, and this is done within repeat until. Again, the use of outer loop, again by the children, it's done with a different color coding to make you understand. And again, the same thing as we talked about, it's a nested loop. And we need a nested loop whenever we are performing bubble sort. Clear? Bubble sort is done through nested loop. Repeat until, and you can see in this, I have initialized, and I'll be very clear, declarations and initializing are two different things. So here we have initialized the variable swap with false, and we have started the for loop for index assignment operator first to last minus 1. Okay, now just take the very quick recap of this, and then inshallah you'll be able to understand very quickly the whole concept. Now this is my index equals to first, which is the value 1, to last minus 1, which is 3. Didn't we do the inner comparisons thrice in the first pass? So when the first pass is happening, the first pass will be always working first to last minus 1, which is first to total elements minus 1. And that's why you can see here the same thing is written for index assignment operator first to last minus 1. If marks of index, my array is as marks. If marks of index is greater than marks of index plus 1, is 45 bigger than 67? So you can see the same thing is explained here. Is 45 bigger than 67? No, right now this is not the case. That's why it will not enter here, and next index will send it back to the for loop. And now the value of index will now become, earlier it was first and value of index was 1, but now the value of index has become 2. So index is now 2, and 2 is compared with the third element. And please be very clear, index plus 1 written here will not increase the value of index by 1 at all. Till the time you don't have the assignment operator, the index value will never change. Just remember, the value will only change when you have the assignment operator. This one, for example. Whenever there is no assignment operator, then the value will never ever change. By the way, here in the for loop, the value is automatically increasing. Now, the first comparison was made between 45 and 67. No change was made, but then it will be between 67 and 13. Is 67, which is on location number 2, bigger than 13, which is on location number 3? Is it true? Yes, children, is the condition true right now? Yes, the condition is true. That's why it will enter the loop. And again, the same concept, temp, which is going to hold the value that is 67, the way we did it right now. See, this is what I did. I moved the value 67 to the temp variable. And then 13 came and sat on this position. 67 came on this position from temp. And this is how the whole values were moved from one place to another. Two values swapped just by using these 3 lines. Ali moving to the temp location, Zen coming and sitting on the position of Ali, and then Ali will come from the temp position. Or in other words, you can say 67 and 13 So 67 moved to the temp location, 13 came and sat on the position of 67, and then 67 later moved from temp to the location of 13. Are we clear, yes or no? Any confusions? So this is how this entire algorithm is handled. So now you are done with this, and very quickly, is there any confusion? We have talked about this scenario with example, and this is the pseudocode, and you can see for yourself. First time the value will be, first two comparisons were made, no, the values were not swapped. Then the second and the third elements were compared, swapping was done. Then the third and the fourth elements were compared, again the swapping was done. And in this manner, we are done with the inner comparisons, and the swapping was done, and we are done with the first pass. And now we are moving, after the first pass is over, now it is the turn to move to this line, last equals to last minus 1. So currently the value of last was 4. So 4 minus 1 will make it 3. So now you can see until not swap or until swap equals to false or last equals to 1. So till the time any of these two conditions is not met, it will continue to operate. It will continue to iterate. And now the value of second pass has started. So second pass has started, so you have to reinitialize the variable swap with false. That is why I kept on iterating that variables are not normally initialized, not normally, because in this case, I need swap variable to be initialized with false inside the inner loop, inside the first loop, because I need to perform the swapping once again. Once again, for index equals to first to last minus 1. Since the value of last is now 3, so 3 minus 1 will be 2, and that is what you can see here. The pass 2 is iterating 2 times. Because I said last minus 1, last value is now 3. 3 minus 1, the comparisons were now started with only 2 comparisons. 45 was compared with 13. Again, the same temp location. Then it will be the 13, 45 and 9 will be compared. And then in this manner, 2 elements have read their positions. And the value of last will be decreased by 1 once again for the third pass, and now it will be working with value of first was 4, now it is 3, and now it is 2. So now first to last minus 1 means 2 minus 1 is going to be once, and that is what you can see pass 3 is only handling the iterations once. 4 minus 3 comparisons were made, and this is how the whole thing is over. Any questions? Ji children, any questions before we finish our lesson?